I can't, Matt. A little video of a system here. I've sent you pictures. A little video is a little more fun to see the real deal. So I'm going to walk around this. Ina's going to be my videographer here, and I'll give you some data on this particular system because it's related to what we talked about for consideration for your home. This is a 20 kilowatt system, guys. 21.8 I think kilowatts, and it's on the grid, 240 volts, about 80 amps AC. And the unique aspect of this system, of course this is in Iowa, it's on the ground, and economics is one of its better attributes compared to other systems because we built this using used railroad ties laid on pea gravel. We'll walk down and take a good look, you'll see it real good. You'll see there's also no pilings, guys. We forego the whole cost of drilling and putting anything in the ground. All we do is scrape the ground, level it, pea gravel it, and put down railroad ties with concrete blocks on top that act as a ballast. And that's commonly done with these systems now. They're called ballasted systems where gravity is your friend, and gravity does all the work. It holds it down. Because it's a low angle, see the angle's about 12 to 15 degrees, that angle keeps the wind down, the wind loading, so this thing will survive 100-mile-an-hour winds, kind of a thing. Compared to being up higher, it takes more money and more materials to make them live through your kind of winds at an angle. This, of course, forgoes all that. As we walk over here, you'll see there's two kinds of solar cells, photovoltaic solar cells, guys. Toward us, you can see the little round squares. That's called monocrystal, a little more efficient. The other ones are called polycrystalline. They're the ones that are more bluish. There's 2 rows of each. There's a total of 72 solar modules. We call them modules, not panels, modules. Each one's about 300 watts rated power. We'll walk along the front of them, then we'll walk on the sides, and you can see for me the fun part is the back side. It's like under the hood. You can see where the wire's at, the electronics, all the mechanical parts. But of course this is the working side. This is where the sun's at. We're facing south here, due south. We're even next to some trees here. But we got the angles, of course, all figured out. So there's no loss here for shading. If you look down, look at railroad ties, 8-footers. Bought at Menards, used here, $15 a whack. Take a look down here, down the aisle here, and there's about a 5-foot spacing between the back of one panel and the beginning of the next one for shading. You can see the shade here. A little bit of spacing so one panel does not shade the other. Let's walk down a row here. And I'll have Ina focus up on the primary funnest part for me is this little black box under here. And that's my life work, guys. The culmination of my R&D work and my doctorate, the whole show. I've got decades and tens of thousands of hours of development time inventing this product. And I am one of the world inventors of this for sure. We call this a microinverter. And that's the transmission, guys. That takes the power from the solar panel, which is DC form, electricity, and it converts it into AC power. And it connects directly to the grid. So we forego, unlike other system methods, there's no central inverter here, Matt, or Kent. All that wiring, high voltage DC wiring, 600 volts, which scares the bejeebers out of most electricians, we don't do any of that. That was one of my life missions when I got in this field, was simplify, 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 and economize, economize, and economize. And so what we've achieved here is a wiring method that's unique. It's really kind of taken by storm, the photovoltaic solar industry, microinverters, because it distributes the inversion function among all these panels all by themselves. They all work in parallel, independent of each other. So if one fails, nothing else is going to stop working. Not like Christmas tree lights. If one burns out, they all stop. Not here. If one quits, they all keep going. It's utterly simple to understand and use and even to wire. So we'll talk more about this, but as we walk down here, you'll see every second panel has an inverter this little microinverter, we call them microinverters, takes 2 solar panels per inverter. So we have each panel about, like I said, 300 watts times 2, about 600 watts of peak power at noon going into each inverter. And they're all parallel connected, just like porch lights. Just like anything else you've wired in your house for your whole life, it's all parallel. Now it's 240 volt, not 110 or 120. And we just walk this row of modules. We call them panels too, but we call each row a sub-array. The whole show here is called a solar array, A-R-R-A-Y. This is a sub-array. There's 4 of them here. There's 18 of these modules in each sub-array, times 4 is 72. When you multiply that times a little more than 300 watts, you get a little more than 21,000 watts worth of AC power, peak power. And all we do, you can see the pipeline, the conduit, the PVC conduit, where the wiring is collecting the power from all different modules, all subarrays, and feeding into one single wiring point here. And this is the working end of everything. This is where the rubber meets the road. The panel powers, the array power, is coming up out of the ground from these conduits down here, collected here into a big combiner box, and all that AC power at peak, about 80 amps, at noon peak time, goes through the meter. It is collected over here by these breakers. I should say it the other way around. Each breaker, you can see them all here, 1, 2, 3, 4, 25 amp breakers, all connect to each one of the subarrays. They all add up. 4 goes into 1, that goes through the meter, spins the meter. I've wired the meter backwards compared to regular utility power so that it runs forward as if it's reading power being consumed like you would in a regular house or load. But we're generating power, we're not consuming anything out here. Everything, all the power that's being metered is going through the meter in a direction that makes it run forward. So that meter is spinning. It's called an analog meter, been around for 100 years. And that's how we know we're making power. And also you can see the numbers, it adds up, just like these meters have forever. But these numbers represent your cash flow effectively, or they represent power not being purchased from the grid. You don't buy their power, make your own, make enough to displace theirs down to 0, like squeeze it to 0 so over a year's time you consume no power from them, so you have no power bill over a year's time. What I want you to see is the wiring here is straightforward, it's simple, it's AC wiring like I can teach and train and have electricians to do this. We can do it, Pete can do it, we can do all this. And this is very straightforward, it's really a mechanical challenge. I'm making a spread round and flat that we can then put some modules down on top of. There's other ways, many ways to bring these modules up off the ground on posts. There's 100 ways to do it. This is one unique way. One of my developments, I've always liked frugality, lowest cost, simplest. I've done all this in a big way. So this is just one outcome of that kind of R&D work, is making solar photovoltaics as simple as it can be and as low cost as it can be. Now this is what I've been running for 5 years, and it's working perfectly, and it will work. The warranted output power on these solar modules is 25 years. They guarantee something like 90% of new power 25 years later, and it won't degrade more than 10%. It depends on the different module, of course. So they just don't wear out. The meters don't wear out. The circuit breakers don't wear out. It's like wiring in your house. It doesn't wear out. There's nothing to wear out. So get something like this, you can set it and forget it. Just go out there and have fun when you don't pay the power bill. That's what it amounts to. Let's take a break, honey.